Hello everyone, this is Dr. Nagalakshmi. Today I'll be talking about corneal anatomy. Cornea forms the anterior 1/6 of the fibrous coat of the eyeball. So the remaining component is formed by the sclera. And this cornea measures an average of 11.7 mm by 11.5 mm by diameter. Horizontally, it measures about 11.7. Vertically, it measures about 11. So, if the diameter is less than 13 microns, then it is known as microcornea. If it is more than 13 microns, it is known as macrocornea. And when you assess the radius of curvature, right? So, when you assess the radius of curvature, it measures about 7.8 mm or approximately 8 mm. So, we should remember it is the curvature, the anterior is more than the posterior. Anteriorly it is more elliptical, posteriorly it is more spherical. So it is not a completely spherical structure as such. And when you see about the thickness of the cornea is thick in the periphery. So if this is the cornea, it is more thick at the periphery, about 670 microns, and in the center it is thin compared to the periphery, which is about 520 microns approximately. And this central 5 mm is the powerful refractive surface of the cornea. And the total refractive power of the cornea is 45 diopters. And the remaining refractive power is contributed by the lens, and this gives the total refractive power of the eye. So we'll be seeing the layers of the cornea. See, the cornea, as we know, has 5 layers conventionally. The epithelium, the Bowman's, the stroma, the Descemet's membrane, and endothelium. In addition to this, we have one more layer, which is the pre-Descemet's layer. The pre-Descemet's layer is known as the Duas layer. I'll be talking about it later. So first let's talk about the corneal epithelium. So the corneal epithelium contributes to 10% of the total corneal thickness. It itself is made up of 3 important layers. One is the basal cell layer. So these are columnar cells basically, which are sitting on a basal lamina. So these basal cells have a very high mitotic activity that we should remember, because they are continuously being replaced. Now when we talk about these basal cells, they are adherent to one another by a component known as desmosome. And they are adherent to this underlying basal lamina by hemidesmosomes. This basal lamina, there are few features you should remember. One, it is a pars positive structure. Second, it is divided distinctly into 2 layers. Lamina lucida, which is 25 nanometers. Lamina densa, which is about 40 to 50 nanometers in size. Now these basal cells continuously multiply, and the older cells move to the above layer by a amoeboid movement. And the next layer is known as the wing cell layer, and further they move to the superficial cell layer. These cells in the superficial layer, right, have a microvilli. What is the function of this microvilli? One, they combine with a component known as glycocalyx, and they stabilize the teophyllum. And the total epithelium of the cornea is a non-keratinized stratified squamous epithelium, and it is derived from the surface ectoderm. Clear? So this corneal epithelium which is present is adherent to the underlying Bowman's layer by 2 important components. That is basically the basal lamina of the epithelium is adherent to the Bowman's membrane via anchoring fibrils and anchoring filaments made of collagen. Anchoring fibrils derived from type 7 collagen, and anchoring filaments which are derived from type 4 and 5 collagen. Let's talk about the Bowman's layer. Bowman's layer, unlike the epithelium, does not regenerate. It is relatively an acellular structure derived from the paraxial mesoderm. This is about 8 to 14 micrometers thick, made of randomly arranged collagen fibrils, mainly type 1, 3, 5 and 6. The next layer is the corneal stroma. The corneal stroma basically contributes to 90% of the corneal thickness. It is about 200 to 250 layers thick. It is generally made of keratocytes. So these keratocytes are nothing but cells, right, which have very rich organelles like mitochondria, rough endoplasmic reticulum. Now they secrete collagen, which is an important component of the cornea. Now this collagen which is secreted is of a diameter 25 to 35 nanometers, and they are arranged uniformly, and the distance between each collagen fibril is also constant, which is 41.5 nanometers. Now this collagen which is present is embedded in a ground substance known as the keratin sulfate and dermatin sulfate respectively. Then we have the two theories which support the corneal transparency in terms of arrangement of the collagen. The first initial theory which was proposed was the Morris theory or the lattice theory. Now this suggested that the corneal transparency is mainly because the collagen fibrils are arranged in a lattice pattern, and the distance between the fibrils is more than the wavelength of light. But I'm very sorry, it is more, they suggested that is more than the wavelength of light. Then came Goldman's, who suggested that it is not the arrangement which is important, it is the size of lamella which is important, which is half the wavelength of light. Okay. Then comes the next layer, which is the pre-Descemet's layer or the Duas layer. Now how did this pre-Descemet's layer come into practice? Now this pre-Descemet's layer was discovered in the year 2013 by Mr. Harminder Singh Dua. Now this Duas layer is 15 microns in thickness, very tough and impervious to air. The main importance, clinical importance of this pre-Descemet's layer comes in use with surgeries like DALK and DELK. Then comes the Descemet's layer, which is a true basement membrane. Now the Bowman's layer, although it was situated in addition to the basal lamina, it is not a basement membrane as such. But the Descemet's layer is mainly the condensation of the endothelial cells, which is forming the Descemet's layer. And the thickness of this Descemet's layer increases with advancing age. That is, at birth it is about 3 microns, which increases to almost 10 microns in adulthood. The next important thing we should remember is this Descemet's layer is made up of two components. One, the anterior 1/3 component and posterior 2/3 component. Now this anterior 1/3 mainly has a banded configuration and is made of type 8 collagen, and this is formed in utero. But the posterior 2/3 component, which is non-banded, it is laid throughout the life. Then comes the corneal endothelium. Now the corneal endothelium, the cells are hexagonal in shape with the surface microvilli adherent to one another by tight junctions. So the cell density at birth, which is 6,000 cells per millimeter square, decreases by 26% by first year of life and further from there on. And these cells which at birth have a diameter of 18 to 20 microns increases to 40 microns with advancing age. These cells have rich organelles because of their high mitotic activity and is made up of numerous metabolic pumps, and it plays a very important role in corneal transparency. The next important thing we should know is the corneal blood supply. Cornea is relatively avascular, but it should receive some nourishment. So the oxygen basically is derived from the tear film. The oxygen which diffuses from the environment into the tear film, this oxygen is supplied to the cornea via the tear film. When the eyes are closed, it is via the lid vasculature and aqueous. And the blood supply, so the entire cornea is transparent, it does not have blood supply as such. But how does it receive its nourishment? This is basically from the capillaries derived from the anterior ciliary artery, which pierce the perichoroidal space and pierce the sclera just at the limbus. So this capillaries supply the cornea. So the nutrients from the capillaries diffuse and supply the cornea. Then let's talk about the nerve supply. So the nerve supply is again by nasociliary nerve. So this nasociliary nerve is a branch of ophthalmic division of trigeminal. So this nerve, which from the ophthalmic division runs the long ciliary nerve. I'm very sorry. See, the nerve supply of the cornea is by long ciliary nerve. Now this long ciliary nerve is a branch of nasociliary nerve, which in turn is a branch of ophthalmic division of trigeminal. So this nerve pierces the perichoroidal space and enters posterior to the sclera, and now it reaches the cornea. At the limbus, it forms the annular plexus. Now these nerves are myelinated here. Then it enters the stroma in a radial pattern, then enters the Bowman's membrane and forms the subepithelial plexus, and then enters the epithelium forming intraepithelial plexus, and these nerve fibers are unmyelinated. Now this unmyelinated fibers is one of the contribution to the transparency of the cornea. In addition to this, there are other features we should remember. Now, the corneal epithelium at its periphery is made of numerous cells. It is made of macrophages, it is made up of Langerhans cells, which play a very important role in antigen presentation. And the corneal epithelium as such plays a very important barrier to the pathogens in terms of antigenicity, in terms of protection. Thank you.